So next is about the law of gravitation. As in the earlier lecture I have explained that law of gravitation was first explained by Sir Isaac Newton. He stated that every body in this universe attract every other body with force, which is directly proportional to the product of masses of those bodies and inversely proportional to the square of the distance between them. That is what the Newton's law of gravitation. So when we say that force is directly proportional to the product of masses, it means that R, that is the distance between the two masses, must be kept constant. And similarly, when we prove another law, that is force is inversely proportional to R square, then in that case, the masses are kept constant. So the same statement is written here, which I have just now explained, that every two objects in the universe attract each other, and this force of attraction is called the gravitational force. The force of attraction between any two material particles is directly proportional to the product of masses of the particles and inversely proportional to the square of distance between them. So we made two laws. One is F is proportional to M1, M2, and another is F is inversely related to R square. So when we combine the law, it will become F is proportional to M1, M2 by R square. So we remove the proportionality sign and we write a final equation, that is F is equal to G M1 M2 divided by R square. That is what the law of gravitation. So now the law of gravitation is given as G M1 M2 by R square. But now suppose we extend this law between the nucleus and electron. The nucleus carries protons and neutrons, exception to hydrogen nucleus, and electron is revolving around the nucleus. So one of the masses, suppose the proton mass, and other mass is electron mass, and the distance between them is the orbital radius. So if we put the orbital radius and we put the masses, that is F is equal to mass of proton into mass of electron divided by, that is the distance between proton and electron, then we find the gravitational force among protons and electrons. The same way we can find the gravitational force between the neutron mass and the electron mass. And from all these calculations, we will come to know that the gravitational force inside the nucleus, within the nucleus, electron pairs will be very, very small. Similarly, among the nucleons of the nucleus, the gravitation will be very small. That is, among the nucleons means among the protons and neutrons with a very small distance, because the nuclear radius is 10 to the power minus 15 meters. That is 1 Fermi. So, if we apply the law of gravitation to the nucleus, the point to remember is that gravitational forces or the law of gravitational forces are mass dependent. So we'll take the mass of proton, we will consider the mass of neutron and divide by distance among protons and neutrons, which is found to be 1 Fermi or 10 to the power minus 15 meters. Then we use the formula F is equal to, that is G into M1 M2 divided by R square. So now we proceed to the next part, that is the vector form. So F12 means force on 1 with respect to 2, and F21 means force on 2 with respect to 1. So these forces are pointing towards each other. They are the attractive forces, and the masses are supposed to be M1 and M2, and R is the distance between the two masses. So that is the vector representation of the law of gravitation. Now G is the constant of proportionality, and the value of G in MK system or SI system is taken as 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. And acceleration due to that is gravitational constant in CGS system will be 6.67 into 10 to the power minus 9 centimeters square per gram square. If we wanted to find the dimensional formula, then we again consider the formula F is equal to G m1 m2 over r square, and from this equation make the subjective equation as g. So when we will calculate g, it will be fr square divided by m1 m2. Then we compute their respective dimensions, and the net formula will become m minus 1 L3 t minus 2. So vector form we have discussed. So vector form is being given here, F12. So G m1 m2 by r square 12, and this is the position vector r12 cap. And other point is given their directions, and another thing is F21 is equal to F12, but the modulus magnitude of F21 will be equal to the magnitude of F12. And we find that gravitational force is the weak force of the nature. Now, there is an important note regarding the gravitation. That is, if we consider the gravitational force and the electrical force between the earth and electron, or otherwise, if we consider gravitational force, that is 10 to the power minus 43. So gravitational force and electrical force. Electrical force is estimated by Coulomb's law of electrical force, that is K Q1 Q2 by R square, and Q1 and Q2 will be replaced by E and E because Q1 and Q2 are the charges of electrons, and Fg is the force of gravitation, that is M1 and M2. So we take two masses, so gravitational force mass dependent, and electrical force is charge dependent. If we estimate the ratios of these two forces, the ratio is found to be very small, 10 to the power minus 43. The range of this force is maximum up to infinity. Now, due to very small value of g that we do not experience the gravitational force in our daily life. However, the gravity is there, but we don't feel it because of the small value of g. As the value of g I have explained you earlier, it is 6.67, 10 to the power minus 11. So the smallness of this force is from the order 10 to the power minus 11. But the masses of celestial bodies are so large that the magnitude of force of attraction between them is appreciable. We can significantly consider it. In the motion of planets and satellites, the force supplies the necessary centripetal force due to which the earth revolves around the sun and moon around the earth. So when we say that earth is revolving around the sun, the gravitational force between sun and earth provides the necessary centripetal force to earth so that it will start revolving around the sun. Now we know that the law of gravitation is G m1 m2 over r square. One of the mass, that is m1, is supposed to be the mass of sun, and m2 is supposed to be the mass of earth, and r is the distance between the two centers. So if we take the gravitational force, then this gravitational force will supply centripetal force, that is mv square over r. So whenever planet is moving around the sun, the planet is under the action of two balanced forces. The inward force is centripetal, comparable to gravitational, and the outward force is centrifugal. So we equate mv square over r by g m1 m2 by r square, and from this we get the value of orbital velocity. So velocity of the planet around the sun can be estimated, and this velocity is supposed to be the the orbital velocity around the sun. But if a satellite is moving around the earth, then that is called orbital velocity of the satellite. Same way, the gravitation between sun and moon, between earth and moon, that provides necessary centripetal force to moon so that it revolves around the earth. Now, the density of earth is assumed to be uniform and particle moves inside the earth, then gravitational force decreases because the shell of material lying outside the particle's radial position would not exert any force on the particle.